Hey, so this week we're going to be looking at the stickleback, that fish that we talked about a long time ago, probably back in August or September. We're going to be looking at inheritance patterns between a couple different populations, and you're going to have to use chi-squared analysis again, which I'm sure many of you are excited for. So I decided to do a little bit of a review with a more simple example that I think Paul Anderson actually did use for you guys before. So anyway, here it goes. Chi-squared analysis, obviously that's going to tell you how your data fits the model that you're using. So in other words, you have something that you see or observe in the like out in the field, and you want to test if that is what you would expect to happen or not. Okay? So for chi-squared analysis, we use this formula. Obviously, chi-squared is the name. That does not mean that to get the answer you take the square root, okay? And then that big E again means take the sum of, and then you have observed minus expected squared divided by expected. And obviously I like to do this using a table. So here's our situation. Let's say that we're going to flip a coin. You have two options when you flip a coin, heads or tails. And in this case, it's not going to be a trick coin. So let's say that I waste a lot of my life flipping coins, and I do this 100 times and get 70 heads and 30 tails. We'd expect in our model that we'd get 50-50, so that gives us an observed and an expected that we can go ahead and plug in. So as you see, let's see if I have a laser pointer right now. I have a pen. Okay, so here you've got your 70-30 for your observed, then you plug in your 50-50 for your expected, and then we're going to go ahead and do that subtraction. So I get 20 heads, negative 20 in tails. I'm going to square those and get 400. Then I'll divide 400 by the individual expected values for each, and I get 8. All right. Then we go ahead and add up these numbers in this far column to take a sum, and that gives us 16. Okay? And then as you know, you need to calculate degrees of freedom. Degrees of freedom are calculated by n minus 1, where n is the total number of outcomes that you could have. So in this case, we have two outcomes, heads or tails. We subtract 1 from that, which means 1 degree of freedom. And then we would go ahead and take a look at our table, usually to 0.05 on your actual formula sheet that you get for every exam, and you'd make sure that your value is underneath that. If it is not, then you are seeing something that you did not expect to occur. If you're going to do this in a more genetics-minded problem, you will have to make a Punnett square and get some values from that. Okay, so I think we'll take a look at that this week, so you should be okay. I would practice the coin flip one again by yourself. Make sure that you're comfortable with it. This will not go away on exams, and it usually appears on everyone each year. Okay, thanks. See ya.